All right, today you are going to learn about integration with sine and cosine and substitution. So the nice thing is we really have done this before. The only thing that's going to be new is the integral of sine x is negative cosine x, and the integral of cosine x is sine x. All right, so having stated those, let's look at example 1. Letter A, I have the integral of 2 cosine x dx. So if there is a constant out front of an integral, or in front, you can just pull it in front of the integral. Okay, so now you're going to look above. The integral of cosine is sine x. So this is 2 sine x, and don't forget, with an indefinite integral, remember this is an indefinite integral. And where you have numbers, that's called a definite integral because you definitely get a number out, okay? I'm just being silly. Okay, in part B, if there is something other than x inside your function, you have to do what's called u substitution. So I have u is 3x minus 5, du is 3 dx. Now I only have the dx, I don't have a 3 anywhere, so I'm going to divide both sides by the 3. So I'm going to put the integral sine of u times 1/3 du. I can pull the 1/3 out because it's a constant. Then I'm going to look here at the integral of sine x. What is the integral of sine x? It's negative cosine x. So this is going to be negative 1/3 cosine, whoops, I lost my letter u there, sorry, cosine u plus c. But I don't actually have a u. U is the 3x minus 5. So that's negative 1/3 cosine, the quantity 3x minus 5 plus c. All right, in part C, do I need u substitution? Yes, you do. U is going to equal 4x. du is 4 dx. Now this time, do you see, here's my 4 dx. I'm going to rewrite this. So this is going to go cosine u du. So you do need to check. We had this happen to us when we did integrals before. All right, so what is the integral of cosine u? Well, it's sine. So this is the sine of u plus c, and u is 4x. All right, let's look at example 2, letter A. So in this one, I'm going to let u equal the 3x squared plus 7x. du is 6x plus 7 dx. So do you see right here, that whole piece, 6x plus 7 dx is going to represent the du. So I'm going to have the integral of u to the 5th du. So when I integrate that, you increase the power by 1, divide by the new power, and you add your arbitrary constant c. Now you can either leave it over 6 or pull that out as 1/6, and it'll be 3x squared plus 7x to the 6th plus c. Okay, final answer. All right, let's go ahead and look at the next one. Letter B. U is going to be the inside function. So if you're wondering, how do you know what u is typically your inside function. So if I let u be x to the 5th plus 3, du is 5x to the 4th dx. You want to scan through the integral. Do you see a 5 with the x to the 4th or a 5 anywhere? No, you don't. So that's when you know to divide it out. Okay, that's when you know to divide it out. So then I'm going to put my 1/5, the integral, cosine u du. So I'm going to integrate the cosine. And let me go back up here. The integral of cosine is sine. And u is my x to the 5th plus 3. So in letter C, I have the integral of 2x e to the 3x squared dx. So I'm going to let u be 3x squared. Du is 6x dx. Now, do you notice I have a 2x? So what would I do here to get a 2x? I would divide by 3. So that's 1/3 du is my 2x dx. So I had part of it. I didn't have a full 6x, but I did have the 2x. So I'm going to get 1/3 the integral of e to the u du. Okay, that one's tricky, so let's really think about that. So then I'm going to get 1/3 e to the u plus c. U is 3x squared. All right, in letter D. Okay, so what I mentioned before is u is typically the inside. Well, do you see I don't have an inside on this one? I have a numerator and a denominator. Well, if I tried to let the numerator be u and I did the derivative, I can't get the bottom. But if I start with the denominator and I take the derivative, I get 8x cubed minus 15x squared dx, which is the entire numerator. Okay, so that's pretty cool. So this is going to give me the integral of 1 over u du. Well, let's remember the integral of 1 over u du is the natural log of absolute value of u. And use your green paper. This should be on the green paper. So then u was 2x to the 4th minus 5x cubed. And don't forget the absolute value symbols. All right, the next example. So now we're ready to go to a definite integral. So what you're going to do is you're going to integrate and then plug in the values of the interval from 0 to pi over 6 in this case. So I pull the 3 out, and the integral of sine is negative cosine. And this is from 0 to pi over 6. So let me refresh your memory here. So this is negative 3 cosine. I plug in pi over 6, and it's subtract negative 3 cosine 0. All right, what is cosine pi over 6? Well, it is radical 3 over 2. Minus a negative becomes a plus. What is cosine 0? Cosine 0 is 1. So this is negative 3 square root 3 over 2 plus 3. And that's my answer. Okay, ugly but true. Very ugly but true. All right, let's look at the next one. I have the integral from 0 to 1 of 3x squared plus 1, the quantity cubed, times 6x. Well, I'm going to have to do a u substitution. I'm going to let u be 3x squared plus 1. Du is 6x dx. All right, now watch this. I'm going to change my limits of integration. My limits of integration are the 0 and the 1. I'm going to plug in that x is 0. If I plug in x is 0, what's the lower limit? Well, that would be 1, because you get 0 plus 1. Now I want you to plug in 1. plug in 1 here. Okay, plug in 1 for x. And what's your upper limit? You should get 4. So now this is going to be u cubed du, but I have new limits of integration. So this is 1/4 u to the 4th from 1 to 4. So that's 1/4 times 4 to the 4th minus 1/4 times 1 to the 4th. So that's what? 256 over 4 minus 1/4, which is 255 over 4. So we don't want any decimals here. And I don't want you using the calculator. I know you know how to do the calculator. All right, on this one, I'm going to let u equal sine x. Now this is where it gets really confusing, because when you're doing derivatives of sine and integral of sine, you don't get the exact same thing. Okay, so when I do the derivative of sine x, I get positive cosine x dx. So I see that here. Then let's plug in sine pi over 4 is either radical 2 over 2 or 1 over radical 2. Doesn't matter which way you write it. And sine pi over 2 is 1. And then I'm going to get u squared du. So that's 1/3 u cubed from 1 over radical 2 to 1. So that's sine cubed. Or no, I'm not plugging in sine, sorry. Crazy person. So then this is 1/3, because I removed the sine x. Okay, so that's 1/3 times 1 cubed minus 1/3 times 1 over square root 2 cubed. Okay, so this one's tricky. So this one ends up being 2 square root 2, because you get square root 2 times square root 2 times square root 2. So that's 1 over 3 minus 1 over 6 square root 2. Ugly, but true. Okay, ugly, but true. All right, recall, you can use definite integrals to find the area under and between curves. So example 4 says find the area of the region bounded by the curve f of x equals e to the negative x squared. The lines x equals 1, negative 1, and x is 1. So I did use my graphing calculator here. And I think I had something like this. So I'm talking about the region bounded here. So you would use an integral from negative 1 to 1 of e to the negative x squared dx. All right, punch this one in your calculator and tell me what you get. I got 1.49. All right, part B, find the area of the region bounded by the curves y equals sine x and g of x is 0.5x. So you're going to want here's the sine x. And here's y equals 0.5x. So you're going to have to find these intersection points. All right, so first find those intersection points for me. Okay, I got 1.895 and negative 1.895. So there was nice symmetry there. So from negative 1.895 to 0, the line is on top. And then from 0 to 1.895, the sine x is on top. All right, go ahead and compute that on your calculator and tell me what you get. I got 0.842. All right, that wraps it up. Go ahead and work on the 13.3 homework.